Due to the graphic nature of this content, viewer discretion is advised. Introduction to Physics, Force, Motion, and Energy. The first topic we will be discussing is relative motion. To describe motion accurately and completely, a frame of reference is needed. A frame of reference can be described as a system of objects that are not moving with respect to one another. Relative motion is the movement in relation to the frame of reference. Now you may be saying, what does this mean? Well, say you walk to school this morning. You know that the school is 2 miles from your home. Your frame of reference is your home. The next topic we will be discussing is distance and displacement. Distance is the distance traveled over a straight line, while displacement is the length and direction of the line from the starting point to the ending point. Displacement gives information about how far and in what direction an object moves from the starting point. Take these 2 warthogs for example. While the warthog may have traveled a great distance, the displacement is 0 because it returned to the starting point. The next 3 topics are acceleration, force, and gravity. Acceleration applies to any change in the object's velocity. To find acceleration, take the final velocity minus the initial velocity over total time. The next topic is force. A force is a push or a pull that acts on an object. A force can cause a resting object to accelerate, or it can accelerate a moving object by changing the object's speed, direction, or both. Gravity is an attractive force that acts between any 2 masses. The next video will demonstrate free fall. That is, the movement of an object towards Earth solely because of gravity. The next topic is projectile motion. Projectile motion is a curved path of an object through the air. It is a combination of horizontal and vertical motion. The horizontal motion is motion at constant velocity, while vertical motion is constant acceleration due to gravity. This next clip will demonstrate Notice the arced or curved path. That is due to the combination of both vertical and horizontal motion. Now we move on to Newton's laws of motion. According to Newton's first law of motion, the state of motion of an object does not change as long as the net force acting on the object is 0. Thus, an object in motion will stay in motion, and an object at rest will stay at rest. Take this video for example. The character in the scene is at rest until he is acted upon by another character. Now we move on to Newton's second law of motion. According to Newton's second law of motion, the acceleration of an object is equal to the net force acting on it divided by the object's mass. A net force causes an object's velocity to change, so the object's acceleration increases. The acceleration of an object caused by the net force also depends on the object's mass. Mass is the amount of matter an object contains. Next up is Newton's third law of motion. Newton's third law states that whenever one object exerts a force on a second object, the second object exerts an equal and opposite force on the first object. Say for example if you were to run somebody over with your car. Now, you are exerting a force on the pedestrian you just ran over, but the pedestrian is also exerting a force on you because you lose momentum. Take this clip for example. Now we move on to the subject of energy. To understand energy, you must first understand work and power. Work is the product of force and distance. Power is the rate or speed of doing work. Once we understand these two, energy is the ability to do work. There are 4 kinds of energy listed in your textbook. We will discuss all of them. First off is thermal energy. Thermal energy is the sum of potential and kinetic energy of all particles in an object. Thermal energy determines the temperature of an object. The faster the particles move in an object, the higher the object's thermal energy. Next up is electrical energy. Electrical energy is the transfer of electrical charges. Lightning bolts, for example, are produced by electrical energy. The electric current in your household is another form of electrical energy. Next is chemical energy. Chemical energy is the stored electrical energy in chemical compounds. When an exothermic reaction occurs, chemical energy is released. A fuel such as gasoline has a rich store of chemical energy. Last but not least is nuclear energy. Nuclear energy is the stored energy that holds together the nucleus of an atom. In the early 1900s, physicist Albert Einstein determined that energy and mass can be converted into each other. Nuclear fission is the process that splits a nucleus apart to release nuclear energy. When breaking apart heavy nuclei, some mass is converted into energy. The last topic we will be discussing is the transfer of thermal energy through radiation, conduction, and convection. Radiation is the transfer of thermal energy by electromagnetic waves moving through space. All objects radiate energy. Conduction is a transfer of thermal energy without the transfer of matter. Conduction occurs within a material or between materials that are touching. Particles colliding with other particles transfer thermal energy. Finally, conduction is the transfer of thermal energy by movement of particles of liquid or gas. The moving particles transfer thermal energy from hot areas to cold areas.